again everyone. Today we will take some problems from the NCERT textbook, and this is our first problem, problem number 4.4. That's fourth problem from the chapter number 4, and this chapter is titled as Motion in a Plane in your textbook. Now this problem says state with reasons whether the following algebraic operations with the scalar and vector physical quantities are meaningful. So we have to identify that these operations, algebraic operations, are meaningful or not. And first statement is adding any two scalars. Can you add two scalars? Will it be meaningful? Yes, of course, it's meaningful. You always add two scalars. For example, mass 2 kilogram and 2 kilogram is 4 kilogram, 5 minutes and 5 minutes is 10 minutes. So this is very much meaningful. And next part is adding a scalar to a vector. Can you add a scalar to a vector? Remember, scalar is just a number. Say, can you add like this? 3 plus vector f. F is vector and 3 is just a number. It has direction, and इसका जो एडिशन एंड सब्ट्रैक्शन है वो दूसरे लॉ से होता है, और स्केलर क्वांटिटीज का एडिशन सब्ट्रैक्शन दूसरे लॉ से होता है. सो वी कैन नॉट ऐड ए स्केलर टू अ वेक्टर. So this is not meaningful. This doesn't make any sense that a scalar cannot be added to a vector. Next part is multiplying a vector by a scalar. Yes, we have seen multiplication of a vector by a scalar. We know this formula, F is equal to ma. Here acceleration is multiplied by mass. Mass is a scalar, acceleration is vector, so a vector quantity is multiplied by a scalar. So this makes sense. So multiplying a vector by a scalar is meaningful. And next part, one more example, I can take one more example. Momentum is equal to mass times velocity. Again, mass is acceleration and velocity is vector. So here we are seeing multiplication of a scalar by a vector. So this is meaningful. Next part, multiplying any two scalars. Yes, that's also meaningful. For example, if you have to calculate distance, say, you know, speed is equal to distance upon time. Here distance, time and speed all are scalar, and if you have to find distance from here, then distance is equal to speed into time, speed multiplied by time. So here we are multiplying two scalars, so that makes sense. So this is very much meaningful that two scalars are being multiplied. Next part is adding any two vectors. So this is very obvious that it is meaningful. We have seen much about it, addition of vectors. And last part is adding a component of a vector to the same vector. Now we will be looking at it. Say we studied about the components of a vector. Say we have this vector in xy plane, this is x-axis and this is y-axis, and this is x component of the vector A, and this is y component of the same vector. Now when you have divided the vector, यहाँ पर हमने वेक्टर को रिजॉल्व कर लिया, उसके कंपोनेंट्स में वेक्टर को डिवाइड कर दिया. नाउ अब ये वेक्टर एग्जिस्ट नहीं कर रहा, ये वेक्टर अपने कंपोनेंट फॉर्म में एग्जिस्ट कर रहा. दिस इज वन पार्ट ऑफ द वेक्टर एंड दिस इज अनदर पार्ट ऑफ द वेक्टर. नाउ ये दोनों कंपोनेंट्स उसी वेक्टर के ही पार्ट हैं. सो इन कंपोनेंट्स को अगर उसी वेक्टर में हम ऐड कर देंगे, दिस विल नॉट मेक एनी सेंस. सो एडिंग अ कंपोनेंट ऑफ अ वेक्टर टू द सेम वेक्टर will not make any sense. So this is not meaningful, because when you divide the vector in its component, the vector has no physical existence. Now the vector exists in its component form. For example, A can be written as ax I cap and ay j cap. Now these are the components. So the vector has been divided into its components, and when you are talking about the components, the vector has no significance. So adding a component to the same vector will not make any sense. So this was our first problem. Now next, let's move to the next problem, and this is our next problem, problem 4.5. We have to tell here a few statements are given to us, and we have to identify whether they are true or false. ये कुछ statements हमें दिए हुए हैं vectors के बारे में, and हमें ये बताना है कि ये सही है या गलत है, true or false. I have skipped two parts of the same question. We will see about those when we will be studying one-dimensional motion. One-dimensional motion जब हम पढ़ेंगे तो उसमें इसमें इस क्वेश्चन के दो और पार्ट थे, उसको हमने स्किप कर दिया, उसके बारे में हम देखेंगे उस टाइम. Now let's take this one. The first statement says magnitude of a vector is always scalar. Now what is magnitude of a vector? We have seen that this is a vector, and इस arrow की जो length है, that is magnitude of the vector, and that length is independent of any frame. इसकी लेंथ बताने के लिए हमें किसी XY या Z एक्सिस की कोई ज़रूरत नहीं है, किसी रेफरेंस फ्रेम की कोई ज़रूरत नहीं होगी. हमें यहाँ पर डायरेक्शन नहीं बताना होगा, जस्ट लेंथ. इस एंड से लेकर इस एंड तक ये लेंथ कितनी है, that is the magnitude of the vector, and that is independent of any frame or XY or Z axes. So this magnitude is scalar. The magnitude of a vector is scalar in any reference frame. कोई भी XY प्लेन हो, XY या कोई 3-dimensional space हो, किसी भी 3-dimensional space में this length will not vary. So this is the magnitude of a vector is always scalar. So this statement is true. Now the next part is each component of a vector is always a scalar. Let's talk about the components. Say we have this vector, say this is vector A, and this is our x-axis, and this is our y-axis, and this will be the component of vector A, say AX, and this will be the component AY. Now, if you are talking about the length of the component, then that is scalar. But if you are talking about the component in particular direction, then this is a vector. If you are saying that this is a component along x-axis, then we are specifying direction also. So this is not scalar, this is vector now. A component along x-axis is a vector. And if you say a component, just if you talk about just this length, then that is scalar. So here this word always makes the statement false. The component of a vector may be scalar if you are not talking about the direction. कौन सी direction में component, x axis के along, y axis के along या z axis के along. अगर हमने ऐसा कुछ नहीं कहा, हमने कहा just component, then that is of course a scalar. But we can associate direction with each component along x axis, component along y axis, or along z axis, or along any other direction. So it can be a vector, it can be a scalar. If you're talking about direction, it is vector. If you're not talking about direction, it is scalar. So this always makes the statement false. The component of a vector is not always scalar. It may be vector or scalar. And next part is three vectors not lying in a plane can never add up to 0. Let's see what is this statement. Three vectors not lying in a plane. So we have three vectors and they are not lying in the plane. तीन vectors हमारे पास हैं और वो एक ही plane में नहीं lie कर रहे हैं. They are lying in different planes. So can they add up to 0? We have seen that resultant of two vectors A and B, A plus B, will be A minus B if the angle between the two vectors is 180 degree. दो vectors के बीच में अगर angle 180 degree हो, then उनका resultant A minus B होता है. and here 180 degree means the vectors are anti-parallel, A and B. The vectors are anti-parallel. Then the resultant will be A minus B. Now this resultant will be 0. This resultant will be 0 only when A is equal to B. If R is equal to 0, then you are getting A is equal to B. So if two vectors of equal magnitude are anti-parallel, are making 180 degree with each other, then the resultant will be 0. That means कि two collinear vectors, अगर उनका मैग्नीट्यूड सेम है, देन वो एड अप होकर 0 बना सकते हैं, उनका रिजल्टेंट 0 हो सकता है. कोलिनियर वेक्टर्स. सो मिनिमम कितने वेक्टर्स हमें चाहिए कोलिनियर वेक्टर्स 0 होने के लिए? 2 वेक्टर्स. 2 collinear vectors can give you a null vector if the magnitude of the 2 vectors is same. Next, what about 3 vectors? Let's see about 3 vectors. So we have 3 vectors, say A plus B plus C, and I'm saying that in तीनों का resultant 0 है. Now how is this possible? I can write C is equal to minus A plus B. C is equal to minus A vector A plus vector B. Now that means C is equal to the resultant of A and B, and direction of C is opposite to the direction of resultant of A and B. A and B का जो resultant होगा उसके opposite direction में है C. और C का magnitude, if you want to write the magnitude of C will be equal to the magnitude of A and B. So now when is this possible? ऐसा कब possible होगा? 2 vectors. If we have 2 vectors, then we can always imagine a plane passing through the 2 vectors. अगर 2 vectors हमारे पास हैं, then these 2 vectors can always lie in the same plane. So we have 2 vectors, and say इसका sum इस direction में है. The resultant of these 2 vectors is this R, and अगर इसका say we have a third vector C like this C, then the magnitude of C and R will be equal, and they are in opposite direction, then this sum is going to be 0. So A plus B plus C will be 0 when the 3 vectors are lying in the same plane. 3 vectors अगर same plane में lie कर रहे हैं तो उनका sum 0 हो सकता है. So minimum vectors lying in the same plane to give you a null vector will be 3. If the vectors are collinear, then there will be 2. Then the minimum number of vectors to give null vector is 2. And if the vectors are lying in the same plane, then to have a null vector, you will need 3 vectors, minimum 3 vectors. Now, what if these 3 vectors are not lying in the same plane? अगर ये तीनों एक ही plane में नहीं lie कर रहे हैं, then can it be 0? Can they give you? Now say we have 2 vectors A and B, and the resultant will pass between A and B. Sorry, this is the resultant vector. So this is the resultant vector. Now अब अगर यहाँ पर कोई तीसरा वेक्टर है जिसको A और B में ऐड करने से 0 आ रहा है, तो वो वेक्टर डेफिनेटली R के ऑपोजिट डायरेक्शन में होगा. So 3 वेक्टर्स, अगर ये C इस प्लेन में लाई नहीं कर रहा तो R के ऑपोजिट नहीं हो सकता, and then A plus B plus C will not be equal to 0. So 3 vectors, if they are not lying in the same plane, then the resultant can never be 0. Now for that you will need 4 vectors, minimum 4 vectors to get a null vector if the vectors are not lying in the same plane. So what we have pointed out here, that minimum 2 vectors are required to give null vector if they are lying on the same line, and minimum 3 vectors are required to have a null vector if they are lying in the same plane, and there are minimum 4 vectors required to have a null vector if they are not lying in the same plane. So 3 vectors not lying in a plane can never add up to 0. So this statement is true. Now, okay, so next problem is 4.6, the 6th problem, and it says establish the following vector inequalities geometrically or otherwise. Here you can see there are some inequalities, and we have to understand it geometrically. We have to comprehend it geometrically. These questions are very basic. It will check your understanding about the vectors, most importantly the geometrical understanding about the vectors. So let's take the first one. Here you can see this is resultant of 2 vectors, and this is magnitude of the resultant of the 2 vectors, and this is magnitude of the first vector and magnitude of the second vector, magnitude of A and magnitude of B. And this says that resultant, the magnitude of the resultant is either less than or equal to the sum of magnitudes of the 2 vectors. So let's say we have 2 vectors, vector A and vector B. I have joined the tail of B to the head of A. Then this will be resultant vector A plus B. So magnitude of A plus B will be this length, magnitude of A will be this length, and magnitude of B will be this length. Then you know from your high school geometry that in a triangle the sum of 2 sides is always more than the third side. So length, this length plus this length will always be more than this length. So what can we write about these 2 lengths? The length A plus length B will always be more than length A plus B. So this is our first inequality, that this length is less than. So A plus B, the magnitude of A plus B is less than magnitude of A and magnitude of B. And अब यहाँ पर ये equal कब होगा? When does the equality sign come into picture? Let's see. If the 2 vectors are collinear, this is vector A and this is vector B. So this length plus this length will be equal to the length A plus B. The resultant will be A plus B. So A plus B length is from here to here. So this length is A plus B. So of course you can see that A plus B length is equal to length A plus length B. So this equality comes into picture when the vectors are collinear. And the next part is we can do the next part from the same figure. This is the same resultant vector, and this is magnitude of the vector A and magnitude of vector B. Now here we are subtracting the 2 lengths. So again from the high school geometry you know that difference of the 2 sides is always less than the third side. So if you subtract this length from this length or this length from this length, whatever length is bigger. So we are subtracting a smaller length from the bigger one. बड़ी लेंथ में से छोटी लेंथ को हम सब्ट्रैक्ट कर रहे हैं, देन जो लेंथ आएगी, जो नंबर आएगा, दैट विल बी लेस देन दिस लेंथ. So in a triangle, the difference of 2 sides is always less than the third side. So we can write this inequality here, that I have to remove it. So in a triangle, the difference of 2 sides is less than the third side. So see here that this is magnitude of A minus magnitude B and then magnitude of the whole A minus B. That means you are getting a positive. That means you are calculating the difference of lengths. Okay. Now, so and when is this equal? When the equality sign comes into picture. So see here, if you have a vector like this A and a vector like this B, then what will be the resultant here? What will be A plus B? If you are trying to add them, then what will be this A plus B? Clearly that will be the difference. That will be the difference of the lengths. So A minus B length will be resultant of A plus B if the vectors are anti-parallel. So this A plus B will also be the difference of the lengths. So if the vectors are like this, then you can write that A plus B is equal to the difference of the two sides. And next part, this A minus B. For that we have to subtract the two vectors. We know the subtraction. For subtracting, you just reverse the second vector. So this is our first vector A, and I reverse the vector B now. So this is minus B vector, and then this is the resultant vector A minus B. Now think geometrically. This is length A and this is length B, irrespective of the negative side, and this is length A minus B. Now again, in a triangle, the sum of two sides is always more than the third side. So that's very clear. And when does this equality sign comes into picture? So again, if the two vectors are like this, A and B, the two vectors are anti-parallel, and you have to subtract them. So for subtracting, we will reverse this B, and then uski tail ko hum A ki head se join karenge. So A minus B in this situation will be, this is vector A, and this is minus B. So this whole length is A minus B. Remember, ट्राइंगल रूल से सब्ट्रैक्शन कैसे करते हैं, दूसरे वेक्टर को हम रिवर्स कर देते हैं. सो यहां पर अगर b है, देन b को हम रिवर्स करके a की हेड पर ऐड कर देंगे. सो दिस लेंथ इज a माइनस b. दिस इज द रिजल्टेंट a माइनस b. नाउ हियर यू कैन सी दैट द सम ऑफ द टू साइड्स, is equal to vector A minus B, the length of A minus B, or the magnitude of A minus B. So if the two vectors are anti-parallel, then this equality sign comes into picture. And the last part, it's that's again about the subtraction. So we have vector A and vector minus B, then this is vector A minus B. And this says that this side is more than the difference of the two sides, which is true geometrically. That difference of the two sides is always less than the third side. So this difference is less than the third side. And when the equality sign comes into picture, so let's see here. This is our vector A. This is our vector A. And this is our vector B. Vector A and vector B in the same direction. And then I have to reverse it. We have to find A minus B. So I have to reverse vector B. Now, how would I do that? See, this is vector A, and I would reverse and add the tail of the vector B to the head of the vector A. So see here, this is minus B. This vector is A and then minus B. Now this length here, this length is A minus B. This length is A minus B, and this whole length is A, and this is minus B. So you can see that A minus B, this length, is simply the difference of the two sides. Is simply the difference. This is A, and then उसमें से हमने B को subtract कर दिया. So the difference is A minus B. So the equality sign comes when A and B are in the same direction. So this was our problem. I hope you have understood it geometrically. Now let's take the next problem. So this is our next problem, the problem 4.7, and this says it's given that vector A plus vector B plus vector C plus vector D is equal to 0. The sum of four vectors is 0. So we have just talked about the addition of vectors adding up to 0. Let's see what the question is saying, then which of the following statements are correct? So we have to identify which statement is correct. Now the first statement is A, B, C and D must each be a null vector. So if all the 4 vectors are 0, then you will get the resultant to be 0. That's true. But this is not necessary. ज़रूरी नहीं है कि सारे वेक्टर्स 0 हों. अगर सारे वेक्टर्स 0 हैं, then of course जो उनका resultant होगा that will be 0. But it is not necessary. So this must in the statement makes it incorrect. There are other conditions when the sum of 4 vectors can be 0. We have talked about it, that if the vectors are not coplanar, then you need 4 vectors for having a null vector. So this is not necessary that A, B, C and D are each a null vector. So this must in the statement makes it incorrect. Next, the statement is the magnitude of A plus C equals the magnitude of B plus D. That's very simple to visualize. Let's see, we have given this statement. Then I can always write that these 2 vectors, the sum of these 2 vectors A plus C is equal to minus B plus D. From the statement given to us, A plus C will be equal to minus B plus D. That means the magnitude of A and C will be equal to magnitude of B plus D. So this statement is correct, that A plus C equals, the magnitude of A plus C equals the magnitude of B plus D. Okay, so the C part is the magnitude of A can never be greater than the sum of the magnitudes of B, C and D. So from this expression I can write that vector A is equal to negative of B plus C plus D, B plus C plus D. That means if I want to write the magnitude, then I would say the magnitude of A is equal to the magnitude of B plus C plus D. So I can write that magnitude of A is equal to the magnitude of B plus C plus D. So the vector A, the magnitude of vector A is equal to the vector sum of B, C and D, the magnitude of the vector sum of B, C and D. So the magnitude of A will be less than the magnitudes of B, C and D. अगर अलग अलग हम ये लेंथ लें B, C and D, then A certainly उस sum से कम होगा. So the magnitude of A will be less than, or maximum it will be equal to the magnitudes of B, C and D. So the magnitude of A is either less than or equal to the sum of the magnitudes B, C and D. And the last statement, so this statement is correct. C part is correct. And the last statement is B plus C must lie in a plane of A and D if A and D are not collinear. So let's solve this. So this vector B plus C, so I can write a single vector in place of B plus C. The resultant of B plus C will be some vector. So I can write that A plus, let us call the resultant of B and C as vector E. So A plus E, where E is B plus C, plus D is equal to 0. Now you have the resultant of 3 vectors to be 0. Then necessarily these 3 vectors must be lying in the same plane. So B plus C, which is vector E, must be lying. Now I can write it like this. Vector E will be equal to negative of vector A plus D. So the vector E must be lying in the same plane of A and D if A and D are not collinear. So for example, like this is vector A and this is vector B. Then this vector E, which is B plus C, will be somewhere here. It will be opposite to the resultant of A plus B. So necessarily these vectors are lying in the same plane if A and B are not collinear. And the next part in the same section D is, next part, the question, the statement says, if A and B are non-collinear, and in the line of A and D, if they are collinear. So if the vector A and D are collinear, then this vector B plus C must be on the same line. So let's see if A and D are collinear. So we have two vectors A and say on the same line there is vector D. Now the sum of three vectors A, D and the vector E, which is B plus C, is going to be 0 only when the vector E is in this direction. Vector E, which is B plus C, will be opposite to the sum of A and D. So if A and D are collinear, then E, which is B plus C, must also be in the same line. So B plus C must lie in a plane of A and D if A and D are non-collinear. Yes, B plus B will be in the same line. And in the same line, sorry, B plus C here will be in the same plane of A and D, and in the same line of A and D if they are collinear. So if A and D are collinear, then B and C will also be on the same line. So this was question number 7. Now let's move on to the next question. Okay, our next problem is a 22nd problem, and this says I cap and j cap are unit vectors. We know they are unit vectors. This is along x-axis and this is along y-axis. Then what is the magnitude and direction of the vectors I plus j and I minus j? So what is the magnitude of this vector and this vector? And also you have to give the direction of the two vectors. And then further you have to find what are the components of a vector A. So this vector is A, इसका component हमें निकालना है along the directions I plus j and I minus j. So you have to find the component of A along this vector and that vector I minus j. So let us first find the magnitude of these two vectors I plus j and I minus j. Let's call I plus j some vector x. Some vector x is I plus j. Remember, this is not a vector along x-axis. I'm using just as a notation. I'm using x as a notation. So I plus j. Now, how to find the magnitude? We discussed about it. The magnitude of vector x will be square root of x component is square, which is 1 here. So 1 square plus y component is square, which is again 1. So 1 square, and this will be square root of 2. So the component of A is square root of 2. And how to find the direction? Direction कैसे पता करेंगे? उसके लिए हमें ये बताना होगा कि ये वेक्टर x axis या y axis से कितना एंगल बना रहा है. So let's find the angle made by the vector with x axis. So I hope you remember we have written that tan theta will be equal to y component upon the x component. If the angle theta is the angle between the vector and x-axis, so y component in this vector is 1 and x component is also 1, so this is equal to 1. Tan theta is equal to 1, so certainly theta is equal to 45 degree. So the direction of the vector is at an angle 45 degree from the x-axis, and the magnitude of the vector is square root of 2. And next, what is the magnitude of the second vector and its direction? Let's call that second vector I minus j, vector y, I minus j. Again, this is not a vector along y-axis. I'm using y just as a notation. Okay, now the magnitude of vector y is again square root of x component is square, which is 1, and y component is square, which is minus 1. So square of minus 1 is again 1, and 1 plus 1 is 2. So the magnitude of vector y is 2. And what is the angle? What is the angle made by this vector with x-axis? So let's first show the vector on the xy plane. So say this is our x-axis and this is our negative y-axis. Then this vector I minus j, remember this is unit vector I and this is unit vector j. So the vector will be somewhere here. If you complete the parallelogram, the vector will be somewhere here. So this vector makes some angle in this direction from the x-axis. If you calculate the angle in clockwise sense, it is written as negative, because the angle is always calculated anti-clockwise. If you take the angle clockwise, then it will be minus theta. It will be some minus theta here. So this minus theta, now how much is this minus theta? See, if this is j, then this is also j, and the magnitude of j is 1. So this length is 1 unit, and this length is also 1 unit. Then 1 upon 1 is 1 again. So in this case, tan theta will be equal to 1. But remember, this angle is negative. So I will write theta is equal to minus 45 degree. This vector makes an angle minus 45 degree with x-axis, and the magnitude of this vector is also square root of 2. Now the next part in the same problem is you have to find the magnitude of this vector along I plus j and I minus j. So if you can remember, we discussed about it, how to find magnitude of one vector along the second vector. You know, dot product of two vectors is AB cos theta. A dot B is equal to AB cos theta. Then if you have to write A cos theta, then this is magnitude of A, this is component of A along B. So A dot B upon B. A cos theta is A dot B upon B. This is component of A along B. So if you have to find the component of this vector along this vector, which we have written x, so अगर हमें A का component x के along लिखना है, then उसको हम कैसे लिखेंगे? The component of A along our x vector, then it will be simply A dot x and divided by, जिसके along हम लिखते हैं उसके magnitude से divide करते हैं. So divided by the magnitude of x. Then what will be A dot x? This is our A vector and this is our x vector. And how to find the dot product? You multiply the x components. 2 into 1 is 2. So 2. And you multiply the y components together. So 3 here and 1 here. 3 into 1 is 3. So A dot x is 2 plus 3, which is 5. And the magnitude of x vector we just calculated, it is square root of 2. So 5, this is 5 upon root 2 is the magnitude of vector A along x vector. The x vector, which is I plus j. And then the magnitude of same vector along I minus j, which we have written by. So let me remove this part. The component of A along our y vector. So on the basis of this, how can we write? A dot y upon y, जिसके along लिखना है उसके magnitude से divide करेंगे. So how will be what will be A dot y? And remember, what is y? Y is A minus j. So A dot y, this is 2 and here it is 1. So 2 into 1 is 2 and this is 3 and here it is minus 1. So 3 into minus 1 is minus 3 and we just calculated the magnitude of y is square root of 2. So 2 minus 3 is minus 1. So this is minus 1 upon root 2. So the magnitude of this vector along I minus j is minus 1 upon root 2. This was to be calculated. So these are the answers. Now let's move to the next question. So our next problem is 24th problem, and this says we have to identify some true and false statements. So it's about scalar quantities. A scalar quantity is one that, so here few properties are given to a scalar quantity. Let's see which one are true. So the first is a scalar quantity is conserved in a process. A scalar quantity need not to be conserved in a process. It is not necessary. ये हमेशा ज़रूरी नहीं है कि कोई स्केलर क्वांटिटी किसी भी प्रोसेस में कंजर्व हो. फॉर एग्जाम्पल स्पीड, किसी ऑब्जेक्ट की स्पीड अगर किसी दूसरे ऑब्जेक्ट से टकरा कर चेंज हो सकती है. If an object collides with a wall, then speed gets changed. It may be equal to the same, but it may also change. So a scalar quantity is not necessarily conserved in a process. Next, can never take negative values. Now अब यहाँ पर नेगेटिव हम कई सारे सेंसेस में यूज करते हैं. कभी कभी हम नेगेटिव डायरेक्शन के लिए यूज करते हैं और कभी हम नेगेटिव एक सर्टेन वैल्यू से कम वैल्यू शो करने के लिए भी हम नेगेटिव यूज करते हैं. फॉर एग्जांपल सेल्सियस स्केल में 0 डिग्री से कम जो टेम्परेचर होता है उसको हम नेगेटिव में शो करते हैं. That is a temperature, a physical quantity, a value of a physical quantity, but that is below a certain value. 0 degree temperature is a finite temperature, and below that temperature is termed as negative. So temperature is a scalar quantity. It can have negative values. So negative doesn't mean that it is less than 0, like numbers. On a number line, the numbers to the left of 0, they are negative. So minus 2 is always less than minus 2 is always less than 2. On a number line, minus 2 is always less than plus 2. But in physical quantities, this is not necessarily true. For example, minus 2 coulomb charge is not less than plus 2 coulomb charge. Here the signs give you a different information. They give you that they say to you that the nature of the charges are different. So minus 2 coulomb charge is not less than plus 2 coulomb charge, unlike the numbers on a number line. So minus and plus signs are used for different senses in different contexts. For example, in case of temperature, the temperature below 0 is negative, and there of course minus 2 degrees Celsius will be less than 2 degrees Celsius. But in case of charges, we also use plus minus for charges. In case of charges, minus 2 coulomb is not less than plus 2 coulomb charge. So it is not necessary that scalar quantities can never take negative values. They can take negative values, and negative sign has different information in different context. The next part is does not vary from one point to another in space. Again, there is no such condition that a scalar quantity has to be same at all points on this in this space. It can take different values in a different point of space. For example, an object is moving and then uski speed change ho rahi hai. At one point the speed is 5 meter per second, and at other point it is 10 meter per second, and at some other point it is 15 meter per second. So speed can change at different points. So it is not necessary that a scalar quantity will have same value at all the points of the space. And the last part of the question is that so all the statements here, they are not correct, they are incorrect, false. It is not conserved, and it is not so that it can never take negative values. It may take negative values, and it may vary from one point to another point in space. So these statements are false. Now let's take the fourth one. Has the same value for observers with different orientations of axes. That's true. For example, if you have 2 kilogram mass, then this is same for all the observers in all the frames. किसी भी फ्रेम में कोई हो, फॉर एग्जाम्पल ग्राउंड पर कोई ऑब्जर्वर है 2 किलोग्राम मास, उसके लिए 2 किलोग्राम है, और अगर कोई ऑब्जर्वर कार में चल रहा है देन उसके लिए भी 2 किलोग्राम मास 2 किलोग्राम है, unless we invoke the special theory of relativity. If you're not talking about the special theory of relativity, if you're talking about in the context of classical mechanics, then mass is not going to be different for different observers. So अगर कोई observer ground पर है उसके लिए 2 किलोग्राम, और कोई observer अगर कार में है या बस में है या एरोप्लेन में ट्रेवल कर रहा उसके लिए भी 2 किलोग्राम will be same. So the scalar quantity the scalar quantity will have same value for observers with different orientations of the axes. For example, if you have this x and y, and अगर इस हम इसको ये axes को हम rotate कर दे से हमने रोटेट कर दिया, एंड दिस इज आवर x डैश एंड दिस इज आवर y डैश, इसको हमने सर्टेन एंगल रोटेट कर दिया. देन xy प्लेन या x डैश y विद y डैश प्लेन, दोनों ही प्लेन में मास 2 किलोग्राम है. So this is not going to be changed. So this statement is correct. That has the same, that the scalar quantity has same value for observer with different orientation of axes. So this was it. Now we will take questions from the exemplar problem, the supplementary of NCERT. Let's move on. Let's move to the exemplar problems. So the first problem that we take from the exemplar problems is problem 4.3, and in this problem we are given two vectors, vector u and vector v, and the values of u and v are u is equal to a I cap and v j cap, and v is equal to p I cap and q j cap. So we have to find the signs of a, b, p and q. A, b, p and q, whether they are positive or negative. We have to find this. So now let's rearrange the vectors. Remember, I can always delocate the vectors on this plane. So I can also draw the same vector b here, the same vector b here. I can move it parallel to itself. So this is our vector b. Now let's see the components of the two vectors. The component of u will be this ux. The component of u along x-axis will be this component, and the y component will be this one. So this is y component of the vector u, and this component is along the positive x-axis. So x component of vector u is positive, and y component of u is also positive. So the components of u have positive signs. Both components have positive signs. So here both a and b are positive. So a and b both are positive, both are greater than 0. And what about v? Let's see. This is the component. This is the component. This is the component of vector v, which is vx, and I can draw negative y-axis. I can extend the y-axis, and this is y component of the vector v. Clearly you can see that x component of v is along the positive x-axis. So the x component is positive, and y component is along the negative y-axis. So y component is negative. That means this p here, this is the x component because it is with I cap. So x component is, you can see, positive, and the y component you can see is negative. So here p is positive, but q is 0. Q is less than 0. So that's what this is what was asked in the problem. Let's move on to the next problem. So next problem from the exemplar problem says problem 15, and it says for two vectors a and b, this is true. That is, magnitude of a plus b and magnitude of a minus b will be equal to 0. So what could be the conditions if this is true? A plus b, the magnitude of a plus b is equal to magnitude of a minus b. So here 4 options are given to us, and remember this is MCQ 2 type. MCQ, this is the second type of MCQ. That means here more than one answer can be correct. So let's check every option. That first option says the magnitude of A is equal to magnitude of B, and that is equal to not equal to 0. Okay, that can be if the magnitude of A and magnitude of B both are non-zero. Still this equality will hold true. But इसके साथ कोई और condition भी दी हुई होनी चाहिए थी. Only this condition is not sufficient. this is not sufficient that A and B both are non-zero. So A and B, A plus B and A minus B, the magnitude of A plus B and A minus B is going to be equal. So here we have to be given some more information. So this cannot be our answer. This is just this information is not sufficient. And next option, that A and B are perpendicular. So let's check this. Now we will solve this. So given to us is magnitude of A plus B is equal to magnitude of A minus B. Now we have derived a formula to find the magnitude of the resultant, and which was, so in the place of A plus B I can write A square plus B square plus 2AB cos theta for the resultant of two vectors, and for subtraction of two vectors I can write A square plus B square minus 2AB cos theta. Now squaring both sides, we will have A square plus B square plus 2AB cos theta will be equal to A square plus B square minus 2AB cos theta. Then A square and B square will be cancelled out from both sides, and take this minus 2AB to the left side, and it will become 4AB cos theta, and that is equal to 0. Now we can also write that AB cos theta is equal to 0. Now we can conclude that either of these three can be 0. If A is equal to 0, then this is going to be 0. If B is equal to 0, then also this is going to be 0. And if cos theta is 0, then this is also going to be 0. So if I say that cos theta is 0, that means theta is 90 degree. That is, the vectors are perpendicular. So if the vectors are perpendicular, then this relation will hold true. So this is a correct statement, that A and B are perpendicular if the magnitude of A plus B is equal to magnitude of A minus B. Then the next option is the magnitude of A and B are equal and they are not equal to 0, and A and B are parallel or anti-parallel. So if these two vectors are non-zero, then this will not be equal to this. The addition will be different and the subtraction will be different. If we are talking about the same two vectors, if the two vectors are parallel, say we have two parallel vectors, say we have two vectors A and B. So if you add them, you will get this length. This is A plus B. And if you subtract them, then you will get something like, if you subtract B, this length from this length, so you will have to reverse B and then sum this length, this part here, this will be equal to A minus B. So clearly you can say that if A and B are parallel, then A plus B is not equal to A minus B. The magnitude of A plus B is not equal to magnitude of A minus B. And the last option is that when either A or B is 0. So we have concluded here that either A or B is 0, then this is going to be true. That means magnitude of A plus B and magnitude of A minus B is equal. So either A, the magnitude of A, or magnitude of B is 0, then this is going to be true. So this option is also correct. So in this question, option B and option D are correct. Now the next problem. Next is the 20th problem, and it says that A, B and C are three non-collinear and non-coplanar vectors. Three vectors are non-collinear and non-coplanar. Then what can you say about the direction of A cross B cross C? So तीन वेक्टर्स हैं जो नॉन कोलिनियर और नॉन कोप्लेनर है, मतलब तीनों एक लाइन पर भी नहीं है और एक प्लेन में भी नहीं है. देन A क्रॉस B क्रॉस C, इसके बारे में हम क्या कह सकते हैं? नाउ So we have three vectors, non-coplanar vectors, but I can always draw a plane passing through the two vectors. So दो vectors A and B से एक plane pass करता हुआ हम show कर सकते हैं. That means A और B को इस plane में हम draw कर सकते हैं. But let's take these two vectors first because it is given in brackets. So let me write this as C. So we can always have a plane that is passing through B and C. So we can say that B and C are lying in a plane. Now, so you know, if you have two vectors x, let's call it P cross Q is equal to some vector R. So we have discussed in vector product or cross product that the cross product, the resultant of the cross product is perpendicular to the two vectors. So if R is equal to P cross Q, then R is going to be perpendicular to both P and Q. R or P, R or Q, दोनों के बीच में angle 90 degree होगा. So the vector B cross C will be perpendicular to both B and C. So the B cross C vector will be somewhat like this. So if it is B cross C, then from the right hand rule, fingers along the first vector and curl your fingers through the smaller angle towards the second vector. Then B cross C is actually into the board. So if I say that B cross B is into the board and say this A vector is somewhere like this. So A vector is somewhere like this and B vector is into the board, and then you are calculating cross of A and B cross C. So let's call B cross C is going to be vector sum E. So B cross C is E. So this vector is E. Then when you calculate A cross E, which is B cross C, so A cross E will be perpendicular to both A and E. So vector the vector E is into the board, and I have assumed that vector A is in this direction. Then A cross C, the inward vector A cross C will be perpendicular to both A and B. So I can show a direction, say this direction, let's call it vector D. So this vector D is perpendicular to the vector inward and also perpendicular to this vector, जिसको हमने assume किया यहाँ पर A. Say this is vector A. So this D is perpendicular to A and also perpendicular to the vector inward. That means D is lying in the plane of B and C. So this whole thing, this whole vector will lie in the plane of B and C. If you first calculate B and C, then you take the cross product with A, then whatever vector you will get finally, that vector will lie in the plane of B and C. B and C, B cross C will be a vector perpendicular to both B and C, and then let's call it E. And if you take the cross product of E and A, then that cross product E cross A is going to be perpendicular to both A and B. So ultimately it will again lie in the plane of B and C. So this was the problem. So we have taken some basic problems to make you understand some basics, the geometrical behavior of vectors, and along the course we will be applying the concepts of vectors in abundance. So get ready with the vectors, the concepts of vectors all the time. We will be using these concepts in most of these situations. And next time we will do unit and measurements. Thank you for being with us. See you next time.